Yesterday we talked about how to create a procedures and what are the how to pass the parameters to the procedure and how to use this and all. So that's what we discussed. And we also checked how to test the procedures using anonymous blocks and all those things. And we did also talk about what is the use of functions and how can we refer them, how can we refer the functions inside the uh, you know how can we refer the functions inside the select statement. So those are all the things that we have checked it. And in the today's class we'll concentrate more on how procedures are written in the data warehousing environment. It's like data warehousing environment and how it can be used. All those things we'll discuss. All right. So in general data warehousing environment, so why do we use procedures? That's what first we need to understand. So generally we write the procedures for dropping the indexes on the table. Um, so let's say um, dropping the indexes. Uh, Dropping the indexes on that. So yeah, we'll send it today. I think team has missed it. We'll send the video tonight. I mean both the videos. And we will also create the, this is for creating the indexes, and sometimes we'll analyze the tables after the data load is done from the Informatica, and also we'll also do that for truncating of the partition and truncate the partition, and at the same time we'll also use the, so these are all the, I mean any other uses which we can do it. So now the primary question is like, why should we drop the indexes before we load the data, or why should we create the indexes after doing this? See, let's say a thumb rule is that if you have more indexes on a table, definitely um, the data loading will become slow. So if you have indexes, data loading will become slow. So that's the reason whenever we are doing heavy loads on the data on the database tables, first we'll drop the indexes, and then we'll recreate the indexes after the data load is done. So now we'll see how the dropping of the indexes will be done using the stored procedure and how it will work, and we'll also see how to analyze the tables and all. Okay, see, one important thing is when you talk about the stored procedures, I mean DDL statements inside the stored procedures, you cannot use DDL statements directly just like a DML. See, yesterday when I have written a code, I have written it saying that insert and commit statement. I've directly written it here, but you cannot write the DDL statement like this. So the DDL statements are not allowed directly within this. So we cannot use the DDL statements directly. DDL statements directly in uh, DDL statements directly in the procedures and functions. So we'll actually make use of dynamic SQL. So dynamic SQL means where the input is not certain, and that statement, whatever the statement that you're actually executing, that we will actually prepare at the runtime and then execute it. See, let's say uh, example for a dynamic SQL, let's say, let me give you a real-time example. So let's say there are three tables. Whenever we pass the table name, using that table name only, you have to insert the data. So table name till the runtime you don't know. There is a table table A, and you have table B and table C. There are some three tables are there, and you're passing the table name as an input to your stored procedure. You don't know which table you have to insert the data, and this table is actually inputted by your program. I mean, you are passing this table name as an input. So you don't know which table you have to insert the data till the runtime. So this kind of requirements, we go for a dynamic SQL. So dynamic SQL means where uh, the statement what you are executing till the runtime, you don't know what statement you have to execute. So based on some inputs from the your execution time, so you need to prepare an SQL statement and then send it. So that is called as a dynamic SQL. So dynamic SQL can be used for all these scenarios, but for executing a DDL statements also we'll use a dynamic SQL. So how do you execute the dynamic SQL inside the stored procedure? That is by using uh, one statement called as a execute immediate. There is a execute immediate statement. Using that, we will actually execute the we will uh, we will execute the DDL statements using this. Now let's try to see how can we'll write a procedures for dropping the index, and one is for creating the index, another is for analyzing the tables. So first procedure, let's try to write the drop index stored procedure. So the procedure is pretty simple. See, what I need to do is I'm going to pass the table name as an input. Okay, so table name, I'm going to pass it as an input at the runtime, and I need to get the drop the indexes whatever is there on the table, and then return the error message in case. So if you find any error, so return that error message back to calling environment. So that is what it is. So how do you define a stored procedure here? By passing the table name as an input. So let me try to define that. So let's say create or replace and procedure. So you need to define a procedure here. So procedure is to drop the indexes. So just write it as drop the indexes. So it is taking two I mean two things. So one is a table name and another is a output. So p underscore uh, table name, or you can pass it as a p underscore table nm. So this is going to be input, and you call it as a varchar2. And another one is, let's say you're passing the, I mean you're getting the error message, so you can even call this as a error message. So let's say input, sorry, out, and this is going to be an out, and you call it as a varchar2. So when you take a look at it, this is what it is. So you're creating a procedure, and that procedure is actually taking a table name and error message as an out. See, one thing that you need to remember here is, so suppose if you know the table name, how can I get all the indexes? All the indexes that are defined on a table. How do I get the indexes defined on a table if I know the table name? So basically, there is a data dictionary which we have discussed yesterday. So that is called as a user underscore indexes. User underscore indexes table will give you the table, I mean user underscore indexes table will give you the list of indexes created on a table. So now what I'll do is I'll actually define a cursor here. So cursor to fetch all the indexes based on the table name. So cursor, let's say get indexes, this is my cursor name. Get indexes is, let's say I want to get only the index name, I don't want anything else. Index name, so select, sorry, from index underscore name, from, let's say, user underscore indexes, user underscore indexes where table name equal to this one. So if you go and see, there is a table name column inside this one. So I'm just using that as a directly. So just use this. Now let's try to execute this, whether it will work or not. I mean, I'm just checking whether it is syntactically correct or not. Okay, you do have a index name, and when you pass the table name, it will give you this. So this is fine. You do have a table name with this. So let me just try to execute. So it is giving you this, and the table name is also there. So you can easily understand index is defined on a what table name and all. So now what I'm doing is I'm actually passing the index name and the user underscore indexes, and then I'm passing this. So I'm going to use a for loop cursor now. So for loop cursor, not like a basic loop. So for, let's say, index name or indnm in, it has to loop through all the records here. It is going to loop through, so loop, and then you do have a end loop. So you're going to use an uh, execute immediate statement. See why we have to use an execute immediate. We cannot write how to drop the index. We need to use drop index and then the index name. So index name is basically, this is the one. So indnm dot index underscore name. So this is what is your index name, what you are fetching from the cursor, right? So if I try to use this and compile, it will throw the error because you cannot use the DDL statement directly inside a procedure or a function. It is not possible. So suppose, let's say, if there is any error while dropping the index, if there is any error, then I want to uh, return the error message back to the this one. So when others, then when others, then, so now let's say you want to return an error message. So for this error message, so I'm just initializing this error message with a SQL ERRM. So SQL ERRM is a error message what you have. So when you try to compile this, what will happen? You're passing the table name and you're returning the error message back to the this one. So try to compile this and see. See, obviously this will give you the compilation error because you are directly using a DDL statement here. So if you try to use here, it has encountered a symbol drop when expecting one of the following. See, it, you cannot define a DDL statement here. So in order to check this, I mean, in order to use the DDL statement and all, how we can use that is your by using a execute immediate. So this is called as a usage of your dynamic SQL. So here you can write the statement saying that drop index, and then you have the index name. There is a space you require, and then pass this index name to here. So if I try to compile now, it will work. See, because at runtime I'm preparing this. So syntactically, it will not check whether your procedure what you are writing syntactically whether it is correct or not. That it will not validate it here. It will not validate. So when you try to compile, now this is compiled. See, procedure is compiled successfully. If you want to check, go and check in this procedure. I'm actually defining in my target schema. So you also define these procedures in your target schema, whatever is assigned to you, because we are going to reuse them in Informatica. I'm going to invoke all these things from Informatica. So for now, you just define it. So let's say drop indexes is a procedure which it is there. So let me, this is a procedure now wherein you are passing the table name and it is dropping the index. So how would I make sure that whether it is working fine or not? All right. So let's try to test this one. Okay. I'm going to pass some table name as an input. So what is a table name? Let's say I'll pass the table name as ODS underscore employee. ODS underscore employee is a table name which I am passing. So try to execute this stored procedure now and see what type of error that you receive. See, it is executed and the process is executed, but there is an error which it is there. Cannot drop the index which is used for the enforcement of the unique or a primary key. What does that mean is there is a primary key constraint which is enabled on this table, and one thing is that whenever you enable a primary key constraint on a table, automatically the primary key index will be created. Automatically the primary key index be created. So that primary key index you cannot drop unless you disable the constraints. Otherwise you cannot drop it. So that is the reason it is throwing the error. This is a genuine error message from your Oracle. So it will not allow you to drop if there is a primary key defined on, I mean, primary key still enabled for a particular column. So if you go and see, this is, you're not able to do that. So let's try with some other table. Let me check whether I have the indexes on the fact sales table. We do have a fact sales table in my target schema. Everybody has it. Okay. So let's try to check. So select star from fact underscore sale. Sorry. Select star from user underscore indexes, where table name equal to fact underscore sales. So this is the, there are no indexes on this. So if you see, none of the indexes are present in my fact sales table. In case for you, if there is a fact sales table, what you do is, what you can do is you can go to the fact sales table and then disable all the constraints in case if you have a constraints defined on it. So just go to constraints and select all the constraints and disable it, because in this also there is a primary key. So I've actually disabled this constraint, I mean, drop the primary key constraint. So that's the reason there is no primary key on this. So now what I'll do, just for our understanding, I'll create one index. You know how to create index, right? So let's say I want to create some normal index. So create index idx underscore representative id on, let's say, fact underscore sales of representative id, which it is there. So try to execute this. Now there is an index which is created. Check it, there is an index which is present in this. Now what I'll do is I'll execute the, I mean, I'll run the same procedure. Now this time, instead of ods underscore employee, I'll actually pass this as a fact sales. Fact sales, I'll pass it and then execute it. Now if you see, basically this has dropped the index. So now if you want to go back and cross check whether it has dropped the index or not, so let's say if you go and check, your index would have been dropped. See here, now there is no index. That means it has dropped the index. Go and check the output column. So it would have dropped already. So output error message will be null. So this is how you can write a stored procedure for dropping the indexes. So just pass the table name as an input and then drop it. So execute immediate you have to use, because directly the DDL statements you cannot use it. You cannot use a DDL statements directly in this. So that is a main important thing that you have to remember for this. All right. So everybody is good on this. Can we drop a primary key? Yes, you can disable the primary key or drop the constraint. Yes, it can be possible. I mean, we did, I think we have defined the primary key, but we didn't drop the primary key. Yes, you can do that. All right. So now let's try to um, create a procedure for creating the indexes. So how do you define a procedure for creating the indexes? So let's check that one. So this is for dropping the indexes. See, in general, what happens in the real time is that whenever we define the indexes on a particular table, we'll always define in some metadata table. Metadata table is nothing but this is a table which will store the list of indexes to be created on a particular table. So basically that is what. So I'm actually defining a metadata table called as a DB indexes. Let's say I'm creating one metadata. You need to concentrate here. These are all the very important topics. When you go to Informatica, you need to remember all these, how we are doing it here. Okay. See, in general real time, what will happen is that we will define one table called as a DB indexes or anything, any name you can give it. It is, this table is actually, we are defining it to store how many indexes are present on each table. I mean, how many indexes you want to create on each table. So to keep it simple, what I'll do is, in this, I will define a column called as a index name. So basically the index name will be of a varchar2 data type. So let's say varchar2 of, let's say, 30 or some 100 characters, which it is there. And similarly, create table db indexes and this. And the next one is about the index type, or index type you can define. See, basically the indexes are of different types. You have a unique index, non-unique index, and you have a bitmap index, all these things, function based index and all, right? So you can define an index type or instead of index type, I just want to capture the table name also. I mean, what table you are creating. So this is also varchar2 of 100, and on which column you are creating you need to also know, right? So index is created on the column level, so not at the table level. So on what column name you are creating on a table. So all these information will capture it within a table. So what we do is, whenever there is an index created on a table, first we'll make an entry into this table. Suppose if you are creating an index on the fact sales table, so we'll make an entry into this. At runtime, whenever you want to create, you're dropping the indexes, right? So for a data loading purpose, when you are dropping the indexes, again you need to create those indexes back. Otherwise, your querying will be slow. When you are reading the data from your tables, it will be slow. If there is no index, obviously the searching mechanism will become slow and you cannot read the data within a minimal time. So why we are dropping the indexes is only the reason is to make the load faster from Informatica. So that is the reason we are dropping indexes. So how do you create them back? So creation of indexes is generally possible by this. So whenever we create any index on any table, first we'll make entry here, so that we'll keep a track of how many indexes are being created on a table. So now what I'm doing is, see, this type of a table will define one, and we'll start making an entry into these tables. I mean, so now let's say I have decided that on a fact sales table, I would like to create some 5 or 6 indexes, or let's say some 3 indexes I want to create, because these are all the columns which are used for your querying purpose. So let me, whenever I'm doing it, first I will do insert into DB indexes. So who is going to make an entry into this table? As a developer, we have to make an entry. So if you're creating some 5 indexes, always those 5 indexes values will be present. So index name, and then you have a table name, and then you have the column name. So which it is there, column name, what it is there. So if you try to define it, let's say first index name, what I'm defining is, let's say, idx underscore representative id. So this is the index name, and the table name, what table you are creating, that is a fact sales table. And the column name, where you are defining that the column name is going to be let's say representative id column. See, this column name, table name, and these are all the things should present already. I mean, table and everything should be there in your uh, database. So this is one. So similarly, let's say I'm defining another one, let's say idx underscore cust id, and this is, let's say, it is defined on the customer id column, and try to insert. Let's say, let's take only 2 records. Now there are 2 records in your db indexes table. So select star from, let's say, db indexes. So try to see this. There are 2 indexes which are there on your fact sales table now, which we have defined. This is a manually we have created this. This is not Oracle table. This is a table which we are creating for our data loading purpose. Okay, so now we have defined the DB indexes. Now my requirement is that I'm going to pass the table name as an input to this, input to my procedure. What my procedure should do is, it should read the data from DB indexes table, and then it should create, if there are some 10 indexes which are available in this table for a fact sales, it should create all the 10 indexes. So likewise, it should do it. Now I'm going to define a procedure which will read the indexes information from the DB indexes table, and it will start creating the indexes on it. So let's try to define it. So I hope everybody is understand here what we are doing it and why we are doing it. Okay. So let me define a stored procedure now, which is called as for a creating of the indexes. So now define a procedure, create or replace, and you need to define the procedure name. So basically, procedure name is going to be indexes, create indexes. So here you're going to pass the table name as a input. So table name is a input, let's say varchar2, and you need to also define the error message. So error message, in case while creating the index, if there is an error, I want to capture that error. So that is your varchar2. Now is, let's say, begin. So you have the begin, and then next one is end, create indexes here. So that is what you have. Now what you do is you need to read all the index names and column names from your table, right? So how do you do that? For that you need a cursor. So cursor CRS or anything, something like CRS get indexes is, now I need an index name and the column name, both is required. So how do you create the index? Create index name and then the table name. So table name is also required, yes. So anyway, the table name is the same thing. So I'll just use it as select star from DB indexes table, DB indexes, where let's say the table name is equal to this one, table underscore nm. Now, whenever you pass the table name, it will retrieve all the indexes which you have defined. Now I need to create one by one index. So how should I do it? So now let me define one um, uh, variable which I call it as VSQL. Let's say varchar2 of some 1000 or let's say 4000. So 4000 characters. I've defined it. So what do? You'll get a multiple values. Obviously, you need to loop through one by one. So how it will happen? Let's say uh, ind names or index, create index or something. Anything. I mean, counter variable you can use anything. So CRI IDX or something. In, you're actually looping through all the indexes, and you're actually looping this one loop and then the end loop. Now I need to create the index. What is the syntax for creating the index? Create index, index name, table, and then the table of the column name, whatever you define. So right. So this this is a dynamic SQL, right? So you need to write that by using a string only. So this is a, at runtime it will prepare the your it will prepare that. So create index, and then you need to know the index name, right? So crs idx dot index name. So create index name. What is the next one? You need to pass the table. So table information you already know it, so you can pass the table name like this. What you can do is you can also get that from the cursor, or you can directly use this value. Anything is fine, both are same, right? So you can use I'll show you how this statement will get prepared. Okay, so table name, and then table name of the column name. So within the parenthesis you need to uh, write that. So what you need to do now is, so within the parenthesis you have to write, so this one again. So this is going to be a string here, and then you need to write the column name. That column name you're going to get again from this. I'm going to show you, it might be confusion for you. So I'm going to show you how this VSQL is actually prepared. So if you break that into this line, so VSQL column name, again once you close that, okay, so here we have to close this. That is the reason it is not appearing properly. And you need to close this information here, which it is present. So I'm going to show you how the SQL is actually prepared. DBMS, I'm just writing for our understanding purpose. So DBMS output dot put underscore line. Let's say I just want to print the VSQL. And now this SQL statement, I have to execute it. If I execute this, then only it will create the index, right? So here I'm going to write, okay, let's first uh, just see how the SQL statement is getting prepared. Okay, let me compile this stored procedure. I'm not creating the index, I'm just showing you how the SQL statement will appear at the runtime. So exception, when others, then let's say error message is equal to SQL ERRM. So let me first compile the stored procedure. Okay, there is an error. Let's try to understand what is the error here. Okay, so let me go back to my procedures, refresh it. Okay, create index, there is a procedure, is an error. Okay, not here. This is syntactically wrong. Okay, that's why it is throwing the create index name, and there is a space here. Okay, you should have a space. Okay, this is fine. And now here you don't require. Okay, let's try to compile. It was actually the string was not properly uh, okay, so error message is equal to, okay, so there is a spelling is wrong. Error message SQL ERRM. Okay, now I think it's compiled. So if you see, now it is compiled. See, I'm just showing you how the SQL statement will be prepared at the runtime. Okay, still we are not using execute immediate to run it. So let's run it. Let's say I'm passing the table name as a fact sales. Let's say I'm defining the table as a fact sales. So how it will uh, prepare the SQL statement for preparing the indexes. Okay, just see here how it is preparing. Create index, index name, table of, and then this. So these statements will get executed at the runtime. So it is reading the information, it is reading the index name as well as a table name as well as a column name, and then it is creating it. So this kind of an SQL statement will be prepared at the runtime. So why do we need to use a dynamic SQL here? Because it's a DDL statement. Okay. Now, if I use this one, so execute immediate, and then I want to run this VSQL. So if I execute it, so uh, basically now what happens is that if I write this v underscore SQL, let's say this is the one, my uh, this one, let me just copy here because this is the latest copy which I'm preparing. Okay, now it is compiled. So I just want to test my procedure. See, now if I go to this fact sales table, okay, let me just show you on the fact sales table whether we have any indexes defined here or not. So if you go and check the fact sales table, and if I go to the indexes column, there are no indexes. True, right? Now here, let me compile this stored procedure. Okay, so I'm compiling the stored procedure with the changes. Now it is compiled. All right. So if I go to this and test it, so if I go to the procedures and then let's say create indexes, run. I'm passing the fact sales as a table name. What should happen now? If I execute this, it should create that two indexes what we have defined on that table. So run it. Now process is exited. Go and check output variable. No error message. Now go and check here. Refresh it. What happened? Something is wrong. Okay. Let's go back and then okay. Still it is not there. 1 second. I think we missed that execute immediate here. I just want to check whether that procedure has it or not. Okay, the execute immediate statement is actually missing here, and that is the reason it has not created. Okay, so let me write it again. Somebody has unmuted, please mute yourself. Okay, so that execute immediate statement is actually missing. So execute immediate of v underscore SQL. So try to compile this. Compile this stored procedure. Now it is compiled. So let's say uh, we do have this one now. Let me just try to test this procedure one more time. See, last time when I've actually tested, it was not, it has not created the indexes because that statement was missing. So when you try to run this now it is proper. There are no errors. Try to refresh it now. What is happening? Okay, there is an error. Missing on keyword. See, syntax is wrong. If you take a look at the this one, I mean, when I executed a procedure, there is a missing of on keyword. So create index name on table. So there should be a on keyword, right? So that on keyword is actually missing. So to do that now, I'm just keeping the on keyword here again. So the syntax is wrong while creating the index. Create index name on table of this. Okay, so just try to compile this one more time and let's run this. Okay, now you got it. So let me run it again. I'm passing the fact sales. Okay, let's check the output. There are no errors. And let's go and check here whether it has created the indexes or not. Now it has created the index. See here, these two are the indexes which we were supposed to create. So the regular procedure, what happens is that in the general real time, okay, whenever we are defining the indexes on a particular table, we'll always define those indexes in some metadata table, something like this. So this is a metadata table which we are using. We'll always make an entry into this table with all the index names, what is the table that we are defining and what is a column name. And whenever you are dropping the index, always you'll go to your data dictionary or a system table, get all the index information and then drop it. And when you want to create the indexes, we'll always go and look at your metadata table what you have defined. So that metadata table is your DB indexes. So it will use that DB index table and then it will create a index for you. So this is a regular procedure what happens. So for maintaining the indexes on a general warehouse environment, what is a procedure that we have to follow? First is that create a metadata table, create a metadata table which keeps the track of all the indexes in your warehouse, all the indexes in your warehouse. In this case, the example is DB indexes table. So which will contain all the indexes. So whatever the index I define on my warehouse, I'll keep track of all these things. And then for a data loading purpose, whenever we are loading a data, bulk data into any table, first we'll drop the indexes on the table, drop the indexes on table before data load by reading the index information info from your system tables or a data dictionary tables, whatever is about. So user underscore indexes and all, or your data dictionary tables. Once you drop the indexes, so generally the third step is that we'll load the data in from Informatica using this. After doing that, so create the indexes by reading the metadata information or index information, reading the DB indexes table. So this is what is a general procedure what we follow. And after the data loading or after creating indexes, we'll always analyze the tables. So there is another statement which you need to learn is about the analyzing of the tables, analyzing of the schemas and all, or analyzing the indexes. So what is analyze keyword stands for? Basically, the analyze means after the data loading is completed, in order to make a better experience for in terms of a reporting, we'll always analyze the tables, because when you analyze the table in Oracle, it will actually keep the track of all the statistics from your all the statistics, and then it will keep that into the data dictionary. So regularly, if you are analyzing the table, the data retrieval will be easy. When you fire a query, it will retrieve the, see, analyze table basically in a simple words, if you have to understand, it will capture the latest statistics about your table. Capture the latest statistics about your table, in data dictionaries. So when your Oracle is executing a query, right? So first it will go and look in the data dictionary. Okay, what is the best path for me to execute this query? So it will understand how many indexes are there. So when you analyze it, it will basically captures all the latest statistics about it, and then stats, latest stats will store, and then it will store the information. So analyzing the table is also a regular procedure which you have to do when you are loading the data from Oracle. So here now I'm going to show you the procedure. So this is what is it. So here, if you look at the procedure, this procedure we have not written, but I recommend you to write this stored procedure as well for analyzing the tables. So I'm just giving you the insight about it. Why do we analyze the tables after the data loading process? So analyze table, you just see it v underscore p underscore table name and then the error message. So what is the syntax is analyze table and then use the table name and then use this as a compute statistics. That means it will actually collect all the statistics and then store it into this. So this analyze procedure, I'm asking you to write it. Anyway, I'll send this file. So in your schema also, you just compile all these procedures and then keep it. So this is more about a dynamic SQL usage in the data warehousing environment. So generally, you might require to write the procedures for dropping the index, creating the index, analyzing the tables, truncating the partition and all. I'm not going in much detail about it because I don't want to confuse you much with so much information. So for a time being, you just concentrate on how to create the indexes using the metadata table, and how to drop the indexes by taking a table name, and uh, then how to analyze the table. So these are all the things which we need to know. And the functions also, I mean, even if you're defining a function for a particular purpose, you can even define them and then do it. I have a question here: how to solve the issues when the index creation fails due to duplicates, like a create a unique index. See, basically, when you are saying that if you're creating a unique index because of the duplicates, it's failing. Obviously, the to resolve that issue, you should make sure that there are no duplicates in your column. right? So once you make sure that there are no duplicates in your column, then only you can create a unique index. Otherwise, you cannot create it. It's as simple as that. So how to solve the problem? It's all depends upon your data. So wherever you have a duplicate, just get rid of all those columns and make sure that all the unique values are stored in that column, and then try to enable the index. It's as simple as that. So that's how we do the data processing in this. So we haven't talked about packages in the PLSQL. So generally, what do you mean by a package? A package is nothing but a group of PLSQL programs is called as a package. Now, a group of procedures, group of functions, and then the global variables, all the things uniquely you're defining. I mean, all the things, if you're defining it as a group, that's called as a package. So package will have two types of components. One is called as a specification, which is called as a package specification, and another is called as a package body. Package specification and the body. So whenever you are compiling the package, first you should compile the specification, then you should compile the body. Okay. Now, what is the specification and what is the body? Okay. So specification is nothing but it's a signature of your methods. In the sense, um, signature of the method in the sense when you are defining a procedure, what is the input, what is the output of the procedure, all those things will define in the package specification. Let's say when you are defining the package, first how to define the package specification, let me tell you. Create or replace, let's say I have something called as a pkg underscore, or you can call it as a util package. So I'm just calling this as a util underscore pkg. All the utilities I'm keeping. So this is a create or replace package. You need to define a keyword. This is for defining the specification as end util package. So whatever it is, you just use this one here. Now, what do you mean by the signature? Signature means it just what input it is taking, what output it is taking. This is called as a signature. So what I'm doing now is whatever the procedures that I've defined, I'm just keeping all the procedures into one package. So procedure for creating the indexes. So if you see, yeah, you need to concentrate here. See, I'm not doing anything new here. So analyze table procedure also, I just want to keep it. This is just all the signatures, you'll keep it. And if you are defining the, okay, so this is called as a specification. So specification means you just define a method and then what input it is taking and what output. You're not going to write the code. Your execution block will not be there in the specification. So this is called as a specification. So now try to compile this. So package util package is compiled. So if you want to go and check, so this is a package. It doesn't have any body. It just have only the specification. Okay. Now to write the body, I mean to compile the body. So it is just that same syntax, but will include the execution block also. That's it. That is what is your body. So now package specification is done. So package specification and package body should have the same name. So let's say when you're defining a body, you just need to use the keyword package body. That's it. Okay. I think you don't require this. Sorry. Create or replace the package. And this is again a same end package name. Yeah, package body is required. Yes. Package body. Uh, I'll just confirm it to you. I'm confused. Okay. So now you have a util package. So what it will contain is that it will have information about all your complete information till the index. Complete body information will be present in case of a PLSQL package. So this is one procedure. And similarly for you're going to get that create index procedure, whatever it is. So we'll just define that also. And you have a analyze procedure also. So this is for analyzing of the table. Okay, it might be confuse you. I mean, when I'm doing so many things here within the single window, it might be confuse you. So just concentrate here. Analyze table. What I have done here is first I have compiled the specification. Okay, so the specification is done. Now I'm actually uh, compiling the package body. So if you try to see this here, and util package and then the semicolon. So I've kept all the packages. Okay, so it is throwing the error. Your body is having an error here. I think we should include the package body here. So it is not taking it. So let me write the package body. So now let me compile it one more time. All right. Package is invalid without the specification. Okay. Why is it throwing that? All right, 1 minute. It's saying there is no specification. We already compiled that specification. Util, okay. Sorry, I have to include. Okay. First, let's compile this. I think we already compiled this. Okay, util underscore pkg, right? So you define that, and this is a package specification, and this one is a body. Package, create or replace package name. Yeah, that's correct one. Okay, let's try without this. Sorry. All right, so we'll try to resolve the error one by one. One moment, let me refresh it. Okay, the connection is closed. Okay, reconnect and go to the packages. Okay, so you have a package specification and body. Okay, I'm editing the body now. Okay, see, create or replace package is invalid. Why? First, let me compile the specification is correct or not. Create or replace, this is also wrong. Okay, let me compile this first. Okay, so this is what, there is some error within the specification itself. So let's try to check that now. Why util package? I think I messed it up. So that is the reason it is throwing the error. I'm not sure how did we get this here. And within the package specification, I have got the body also. I mean, procedure for this. I'm not sure how it happened, but anyway, let's delete all of them. And now see, this is a specification what I have. Okay, now let me just compile this. I just defined only the this one. Now this is compiled. Now it is proper. Your specification is at least valid now. See here, it's valid. So let's try to compile this time the package. Yes, this is also compiled, package body. So within the specification you just need to define what it is. So it's a simple way to get it is you can just go and then click on new package. And let's say if I want to define a package one, so it just defines all the whatever the statement that is there and start entering the declaration types. That's it. Okay, so if you want to define a package body, you can just define even the package body as well. So this is package specification and this one is a package body. So package specification and body should have a same name, and whatever the signature that you are defining in the package specification, it should also have the same thing. See, let's say here in the drop indexes, I have a two inputs, I mean one input and one output. In the specification, in the body, if I'm keeping two inputs and one output, it will not work. So it should have a same specification and then do that. So what is the advantage of the package and why do we need to go for a packages? Why can't I start defining the standalone procedures like this? Why should I go for explicitly for a package? Uh, Standalone procedures, basically whenever you invoke it, it will actually load it into memory. Every time you invoke it, it will load into the memory and then execute it. What will happen in case of a packages is that um, so you have a group of programs which might be called sequentially. Okay, so if I invoke any one program within the package, your PLSQL engine will load all the contents within the package into memory. What is happening is, let's say you're invoking program A, it is also loading the contents of program B, C, D, E, F, everything. It is loading it. Why? Because anyway you're going to reuse them again. Anyway you are going to invoke them in your subsequent calls. See, since it is loading the entire contents of the package into the PL/SQL memory, so the packages are advantageous than your procedures. Procedures are basically standalone things. Every time you invoke it, it will load it. So if you are keeping all of them through the package, all the contents will be readily available in the memory and the execution will be faster. And also organizing of your programs is easy. So if I am keeping all one module related programs into one package, then I can refer all of them at the same place. And you can also make use of the global and the local. See, global means like a public. What do you mean by a public variable and a private variable? Public variable means if you are defining anything within the package specification, that becomes a public. Public means you can use them anywhere in your program. If you are defining only in the body, that becomes a private. Means that private program can be used only within the package. It cannot be used outside the package. Let's say now, see here, let's say analyze table is something that which I'm not defining in the package specification. Okay, package specification I'm not defining it, and in the package body only I'm actually defining the this one. See, my program is still valid. In the package specification I have two things, and in my package body I have three programs. One is drop indexes, create indexes, and then analyze tables. So this create index, drop index are called as a global programs or a public ones because you have defined them in the specification also. If I look at the analyze table I just use that in the your package body only. You're not using it. So this is called as a private program. So anything whatever you define in the specification, that becomes the public. If you are defining only in the this one, that becomes a private. So it's as simple as that. So please, this is about the packages. I mean package specification and the body, and you do have all the kind of a this one. So let me capture this information here in the okay. So this is a specification, and next one is your package body. So this is more about your PLSQL, like how you can use the PLSQL in the Informatica projects. So in the Informatica projects, why do we use? And most of the cases this, and also more on the partitions, like how to truncate the partitions and how to drop the, I mean exchange the partitions and all. So I'm not going in detail about the partitions because it's already I have shared so much information, and probably if you understand all these, then you can slowly explore about all those later on also. This is pretty much on the dynamic SQL, how to use the uh, PLSQL packages and how to use the PLSQL procedures and all. So these things, whatever the procedures that we have defined today, you're going to invoke that from Informatica. I'm going to show you how to invoke all these procedures from Informatica. So I want you to compile all these procedures in your target schema so that you can invoke these things from Informatica. Okay, so these procedures I'm going to share it with you. So let's say uh, this is a packages today what we have learned. So any questions that you have, probably you can go ahead now. Packages, and compile all these things and practice and understand each and every word that we have discussed today. And there is one more stored procedure which is required for us for updating the job control table. I'll also include this. Just try to understand what it is. Okay. I'll also include this one. So this is a stored procedure for updating the job control table, and just understand this also. Anyway, this procedure also we are going to use it. It has a lot of uh, things in it. Okay, so just understand what it is. All right. So yes, it's a very good question. So what is a DB link and how it works? All right. DB link is basically which will be created between the two databases. So it's like now I have an Oracle database. I mean, a DB link definitely it works between the two homogeneous databases. Okay. So this is also a good concept. I mean, you need to remember this for a real time purpose. So let's say this is my enterprise data warehouse and this is an Oracle database which I have. And there is a user called as user A. Let's say there is a user in this, that user is called as a user A. Okay. Now there is another table, I mean another database which you are actually using it as only for staging. Here you are storing all the dimension tables and fact tables, and all the staging tables are present in this database. Okay. Now there is a staging user called as a stage A. Okay. These are the two different databases altogether. It could be on the same machine or it could be on the two different machines. For better understanding, just understand that two databases are present in the two different servers. So this is on the server 1 and this is on the server 2. Means when I say server 1 and server 2, it's two physical machines which are present, and you have created the two different databases. Now there is a table which it is present called as, let's say I have a table called as stg underscore customer. Okay. So this is a table which is present in my staging. I want to access this table by executing a query within this database. I need to access the stage underscore customer table, but my query I'm executing in it in this database. So how do you access the table from the other database? It's altogether the two different databases, not the two schemas. Two different databases which are available. So when you want to read the information from the remote database, so then we'll make use of the DB link. DB link is an object. Okay. So here I'll actually create a bridge between this database and this database. This is called as a DB link. So we'll create a DB link. Let's say my DB link name is EDW underscore, let's say EDW stage. It's basically I'm creating a DB link between this and this. So there is a syntax, separate syntax for it, which you need to follow. And I have created now. Now I want to access this table by executing a query from here. So when you're executing a query here, you need to write a query something like this. Select star from stg underscore customer. So you are writing this, and this query it has to execute in this database. So we'll use @db link. We'll write the query select star from table name @db link. What is the DB link name? EDW underscore EDW stg. So when you write this, your Oracle understands that okay, this has to be executed in this database. So it will go and execute in that, retrieve the information and then show it to you. It is basically executing the query over the network, not in the database. So that's how it works. So this is called as a DB link. So again, you have two types of a DB link. One is called as a private and another is called as a public. So this is pretty much about what is a DB link is all about. Okay, so whenever you want to access it from that one, so you will use the DB link approach. All right. So now suppose let's say this is Oracle database and this is Oracle database. That's why we were able to create it. So if this is SQL Server database and this is Oracle, can I create a DB link? No, it is not possible. So Oracle can talk to only Oracle. Oracle cannot talk to SQL Server. Oracle cannot talk to Teradata. So that is not possible using this. So that is a thing with a DB link, how to execute the queries and all. So all right. So that's it I have for the day. And any more questions, I'll probably answer all of your questions related to hands-on. And in the next week onwards, it could be helpful. So if you could log in at 6:30 a.m. every day. So it is at 9 o'clock. We'll send a note. We'll send a note to everyone saying that. So the class will start at 9 p.m. EST. So I repeat, class will start at 9 p.m. EST, and you just convert that into your time zone, and according to IST it is 6:30 a.m. IST. 6:30 a.m. So please plan accordingly. Sorry for the change in schedule. I mean, because